In this session, I am going to explain about the problems on Z parameters. So, in this is the first problem that I am going to explain. This problem, what this problem here is, test results for a two-port network are, so there are some tests are conducted on a two-port network. So, from the test, so it is test 1, test 2. So, whenever port 2 is open circuited, we got the I1 as 0.1 at an angle 0 degrees amperes, V1 as 5.2 at an angle 50 degrees volts, V2 is this much of voltage at the port 2. And with port 1 open circuited, these are the results that he obtained. So from these results, I need to find the Z parameters. So let me explain this problem. So solution. So there is a two-port network. There is a two-port network. It is a two-port network. For this two-port network, we know that this is V1 and this is I1. This is V2. This is I2. So for this two-port network, these results are obtained here. So whenever port 2 is open circuited, this is the result. Whenever port 1 is open circuited, this is the result. So I need to find the Z parameters. So what are these Z parameters actually? V1. If I write this vector matrix equation for the Z parameters, then this is V1 and V2. These variables can be expressed in terms of I1 and I2. So this is I1 and this I2. It is Z11, Z12, Z21 and Z22. So from this, V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. So from these equations, we can get the values of Z parameters, that is Z11, Z12, Z21 and Z22. So Z11, this can be obtained by making this I2 is equal to 0. So V1 divided by I1 at I2 is equal to 0. And if I2 is equal to 0, I can also get the value of Z21 from this. Z21 is equal to, now Z21 is equal to, what is this Z21? V2 divided by I1 at I2 is equal to 0. Now if I want to find this Z12 and Z22, I need to make this I1 is equal to 0 here, I1 is equal to 0 here. So this is for the first one. That means if I2 is equal to 0, that is port 2 is open circuited. For port 2 is open circuited, then this is this one. If I1 is equal to 0, that means port 1 is open circuited. It is port 2 is open circuited. Open circuited. This means port 1 is open circuited. If port 1 is open circuited, means I1 is equal to 0. If I substitute this I1 is equal to 0 in these expressions, then I will get Z12 is equal to, from this Z12 is equal to V1 divided by I2 at I1 is equal to 0. And this Z22 is equal to, this V2 divided by I2, V2 divided by I2 at I1 is equal to 0. And whenever this port 2 is open circuited, these are the results that he obtained, that is I1, V1, V2. Here V1 value is 5.2 at an angle 50 degrees divided by I1 value is 0.1 at an angle 0 degrees. So if I obtain this value, it is 52 at an angle 50 degrees. It is Z11. Next, Z21. Z21 value is, it is V2 by I1. When port 2 is open circuited, V2 value is 4.1 at an angle minus 25 degrees divided by I1 value is 0.1 at an angle 0 degrees. So it is 41 at an angle minus 25 degrees. Next, if port 1 is open circuited, the value of V1, port 1 is open circuited, these are the results that he obtained. So V1 value is 3.1 divided by 3.1 minus 80 degrees divided by I2 value is 0.1, this is also 0.1 at an angle 0 degrees. V2, it is 4.2 at an angle 60 degrees divided by, and I2, this is 0.1 at an angle 0 degrees. Now I can write this one as 31 at an angle minus 80 degrees, and it is 42 at an angle 60 degrees. So after calculating all these parameters, I am going to write these parameters in matrix form. So that is Z11, Z12, Z21, Z22, that is equal to, this is Z11 value, that is 52 at an angle 50 degrees. Z12 value is, this is Z12 value, that is 31 at an angle minus 80 degrees. Z21, it is 41 at an angle minus 25 degrees. Z22, 42 at an angle 60 degrees. So these are the Z parameters for this problem. This is how we need to solve the problems for this type of problems. Next problem, this is the next problem. Find Z parameters for the network shown in figure. So this is the figure. So from this I need to find the Z parameters for this network. So to find the Z parameters, so these are the Z parameters. How to calculate the Z parameters? Z11 is equal to V1 by I1 at I2 is equal to 0, and Z21 is also that is equal to V2 by I1 at I2 is equal to 0. Z12 is equal to V1 by I2 at I1 is equal to 0. Z22 is equal to V2 by I2 at I1 is equal to 0. That means this problem we can solve in two ways. So first let me explain the first method here. First method. In two methods we can solve this problem. So this is the first method. In this first method I am going to make this to find this Z11 and Z21, I am going to make this I2 is equal to 0. That means this port 2 is open circuited. So if I2 is equal to 0, then this circuit, this V1 is equal to, if I write the KVL for this loop, V1 is equal to I1 into Z1, and this current is 0. So this current is going like this, and this total current will enter into this Z2 because no current will come from this branch. So it is plus, that means this voltage is equal to this voltage plus this voltage. So I1 into Z2. So the same thing I can write as Z1 plus Z2 into I1. Next, so here from this V1 by I1 is equal to Z1 plus Z2, and this V1 by I1 is nothing but this Z11 at I2 is equal to 0. So Z11 is equal to V1 by I1 at I2 is equal to 0, that is equal to Z1 plus Z2. Next, for this I can also find this Z21 by making I2 is equal to 0. So if I2 is equal to 0, then the value of V2, this voltage is equal to, actually this voltage is equal to this voltage plus this voltage as per the KVL, but this voltage will become 0 since there is no current is flowing through this branch. So this voltage is equal to this voltage 0 plus this voltage. So this voltage, what is this voltage? That is, I can write it as V2 is equal to, this voltage is the current flowing through this branch is I1 into Z2. So it is I1 into Z2, and this Z21 from this V2 by I1, let me calculate V2 by I1 is equal to Z2. So Z21 is equal to V2 by I1 at I2 is equal to 0, that is equal to Z2. So this is Z21 and it is Z11. Next thing, we need to calculate this Z12 and this Z22. So I am going to put I1 is equal to 0. That means port 1 is open circuited. I make this port 1 is open circuited so that no current will flow through this branch. Now let me write the KVL for this loop so that I can find the value of Z12 here. So this is the circuit here. So this is V2 and this is I2. This is V1. This current is I1 is equal to, I am making this current is 0. I Z1, it is, I think it is Z2. It is Z2. This is Z3. Now I need to find this Z12. Sorry, Z12, right? This Z12 and this Z22. Z12 is equal to V1 by I2 by making the input port open circuited. That means I1 is equal to 0. Z22 is equal to V2 by I2 at I1 is equal to 0. Now write this KVL equation for this loop. So V2 is equal to, this current will come up to here. Since there is no current flowing from this, so this total current will enter into this Z2. So whatever the current that is flowing through this, the same current will flow through this Z2 also. That means this Z3 and Z2 are in series. So V2 is equal to I2 into Z3 plus I2 into Z2. So this voltage is equal to this voltage plus this voltage. So now from this, if I take I2 as a common here, it is Z2 plus Z3. It is V2. So what I need to find here, Z22 from this is equal to V2 by I2 by making I1 is equal to 0, that is equal to Z2 plus Z3. So I calculated the value of Z22. Now I need to find this Z12. So it is V1 by I2. So I need to write the KVL equation for this loop because it involves voltage V1 here. So since no current is flowing through this, the voltage drop across this one is equal to 0. So this voltage is equal to this voltage plus this voltage. So since this voltage is 0, this voltage is equal to this voltage. This voltage is equal to the current flowing through this is I2 into Z2. So V1 is equal to I2 into Z2, and this Z12 is equal to V1 by I2 at I1 is equal to 0, that is equal to Z2. So now the Z parameters for this type of network, Z parameters Z11, Z12, Z21, Z22 is equal to the Z11. Just now we calculated this Z11 as Z1 plus Z2. Z1 plus Z2, and this Z12 it is Z2. Z21 it is Z21 is Z2 here. Z21 is Z2. Z22 value is Z2 plus Z3. So this is the first method of solving this type of problems. And second method, normally the second methods are preferred to solve any problems. So let me explain the second method here. Second method. So in this second method, just draw the circuit. This is the circuit. So in this second method, we should use the mesh analysis. After using this mesh analysis, we will calculate these Z parameters, Z1, Z2, Z3, this I2, this V2. Now there are two loops are present here. Let us consider it is loop 1. It is loop 1 and it is loop 2. Since the current is flowing like this, I am taking the direction of this loop is like this. So for loop 1, I am writing the KVL mesh equations here. So V1 is equal to I1 into Z1 plus this current plus this current. This is the current I1 and this is the current I2. So this I1 plus I2 into this impedance offered by this branch is Z2. So if I take I1 as a common here, I1 into Z1 plus Z2 plus I2 into Z2. It is V1. Let me represent this equation as 1. Next, for loop 2, so I am going to use this mesh equations here. So this voltage is equal to this voltage plus this voltage. So that is V2 is equal to, it is I2 into Z3 plus I2 plus I1 into Z2. So this voltage is, the current flowing through this is I1 plus I2 or I2 plus I1 into Z2. Now this V2 is equal to I1 into Z2 plus, if I take I2 as a common, it is Z2 plus Z3. So let me represent this equation as 2. Now I need to find this Z11. Z11 is equal to V1 by I1 by making I2 is equal to 0. And Z21 is also V2 by I1 at I2 is equal to 0. So now if I use this equation 1, I am able to get the value of V1 by I1 by making I2 is equal to 0. So from equation 1, V1 by I1 at I2 is equal to 0. That is equal to Z11. That is equal to, so if I make I2 is equal to 0 here, if I substitute, so V1 by I1 is equal to Z1 plus Z2. So this is the value of Z11. Next, this Z21 I can find by calculating this V2 by I1. So I have to use this equation number 2. If I substitute I2 is equal to 0, I am able to calculate V2 by I1, that is equal to Z2 here. So from equation 2, that is Z21 is equal to V2 by I1 at I2 is equal to 0. That is equal to, so it is substitute I2 is equal to 0 here. V2 is equal to, V2 by I1 is equal to, it is Z2. So this is the value of Z21. Next, if I want to find this Z12, Z22. So Z12 is equal to V1 by I2 by making I1 is equal to 0. Z22 is equal to V2 by I2 by making I1 is equal to 0. So from V1 by I2, so this V1 by I2, so where is this one? So if I substitute I1 is equal to 0 in this expression, I am able to get V1 by I2. So from equation 1, this Z12 is equal to V1 by I2 at I1 is equal to 0. That is equal to, so I1 is equal to 0, V1 by I2 is equal to, it is Z2. Next it is V2 by I2. So this is equation number 2. From equation number 2, I can get the value of V2 by I2 by making I1 is equal to 0. So from equation number 2, Z22 is equal to V2 by I2 at I1 is equal to 0. That is equal to, it is Z2 plus Z3. So this is the second method. Normally the second method is preferred to solve the problems. Okay. Next this is the problem. So for this problem I need to calculate the Z parameters for this network. So whenever these type of networks are present, then how to solve the Z parameters? So first you write this time domain network into frequency domain network or S domain network. In S domain network or frequency domain network, these inductors have to be replaced with their its equivalent circuit. So this is resistance, and wherever the inductance is present, it is normally represented with LS. The value of L here is 1, so it is 1 into S, that is equal to S. And here this is the resistance, here also it is LS, so L value is 1 here, so it is S. So this is the frequency domain network or S domain network. So the current that is flowing through this is I1, it is 1 ohm, and this is the current I2 flowing in this direction, so it is V2, plus and minus it is V1. Now you know that the current that is flowing through this branch is I1, this current flowing through this branch is I2. So let me represent these currents. I am going to use the second method to solve these Z parameters here. So it is I1 and it is I2. So let me represent this current as I3, the current that is flowing through this as I3. Now to find these Z parameters, normally this how to find this Z parameter Z11 is equal to this V1 by I1 by making I2 is equal to 0, and Z21 is equal to V2 by I1 by making I2 is equal to 0. Next, Z12 is equal to V1 by I2, I1 is equal to 0. Z22 is equal to V2 by I2 at I1 is equal to 0. Now let me write the mesh equations for these 3 loops here. After that I will try to find these Z parameters. So for loop 1, write the mesh equation for this. So here it is V1 is equal to this I1 into 1 plus S into I1. So that is equal to, if I take I1 as a common here, is S plus 1. So it is V1. Now let us represent, it is S into I1 plus I3. It is I1 plus I3. So plus I3 into S here. So it is, here I did a mistake here. Actually the direction of the current, these two current directions are opposite. So it should be minus here. So I1 into 1, it is I1 minus I3. So it is I1 minus I3 into S here. So it is minus I3 into S. So it is equation number 1. Let us represent it as equation number 1. Now for loop 2, if I write the mesh equation for loop 2, so what is this? V2 is equal to I2 plus I3 into S. So the current flowing through this branch is I2 plus I3. So into S it is. So it is equation number 2. Next for loop 3. So if I write the KVL equation for this, so I3 into S, this current flowing through this branch is I3 minus I1. So it is I3 minus I1 into S. If I take this current, so if I take this current leaving terminal as reference, so it is minus I3 minus I1 into S here. So this one minus I3 into 1. For this one it is minus I3. So it is I3 plus I2 here. So minus I3 plus I2 into S. So the current that is flowing through this branch is I3 plus I2 into S is equal to 0 here. So if I rewrite this expression, then I will get it as so it is I1 into, it is minus into minus, it is plus. So it is I1 into S. So S2 terms here, minus I2 into S here. If I take minus I3 as a common, so it is minus I3 into S. Here it is plus 1, this one it is plus S, so that is equal to 0. So I can rewrite this equation as I1S minus I2S is equal to I3 into 2S plus 1. Okay, so from this I can write this I3 is equal to S divided by 2S plus 1 into I1 minus S divided by 2S plus 1 into I2. So why I am writing this I3 in terms of I1 and I2 is to find this Z11, it is in terms of V1 and I1. That means to find this Z parameters, these equations should be in terms of V1, I1, V2 and I2, but it should not be in terms of I3. So I need to convert these equations in terms of V1, I1, V2 and I2. So I need to replace this I3 in terms of I1 and I2. Because of that reason only I wrote this I3 equation in terms of I1 and I2. So let me substitute this I3 in this equation 1. So from equation 1 and 3, from equation 1 and 3, what I can write here is V1 is equal to I1 into S plus 1 minus, in place of I3 if I substitute this value, that is I1 into S divided by 2S plus 1 minus I2 into S divided by 2S plus 1 into this S here. Yes. So now this V1 is equal to I1 into S plus 1 minus I1 into S square divided by 2S plus 1. Minus into minus, it is plus, plus I2 into S square divided by 2S plus 1. If I take I1 as a common here, so it is V1 is equal to I1 into S plus 1 into 2S plus 1 minus S square divided by 2S plus 1 plus I2 into S square divided by 2S plus 1. So if I multiply this, it is I1 into, it is 2S square plus S plus this 2S, 3S plus 1 minus S square divided by 2S plus 1 plus I2 into S square divided by 2S plus 1 here. So it is V1. So it is 2S square minus S square, it is plus S square. So this I can write as S square divided by S square plus 3S plus 1. So this the same expression I can write as V1 is equal to I1 into S square plus 3S or 2S, S square plus 3S plus 1 divided by S square plus 3S plus 1 divided by 2S plus 1 minus plus here plus I2 into S square divided by 2S plus 1 plus I2 into S square divided by 2S plus 1. So let me represent this equation number as fourth equation. Now I need to write this expression also, equation number 2 also, in terms of I1 and I2. So replace this I3 with this equation from equation number 2 and 3. So from equations equations 2 and 3. So what this equation, V2 is equal to I2 plus I3 into S. So here it is V2 is equal to I2 plus I3. So here in place of I3, what is the value of I3 here? So this is the I3. So first let me divide this equation. It is V2 is equal to I2 into S plus I3 into S. So let us consider this one as equation number 2. So I2 into S plus I3. I3 is S divided by 2S plus 1 into I1. S divided by 2S plus 1 into I1 minus S divided by 2S plus 1